Hi everyone, this is Dan from the North Country Children's Museum, bringing you another science experiment that you can do under quarantine, which is really appropriate because when you're under quarantine, as you might be, they're going to give you a little thermometer, and it's actually not that bad. Someone calls you every day to check up on you, see how you're doing. It's like having a mom and dad that care about you. That's a joke, mom and dad. It's just a joke, I swear. Um, so for this experiment, what you're going to do, we're going to be making what's called a Cartesian diver, which is literally just a pressure-based experiment where we're going to see how changes in pressure can cause things that normally float to sink. And you can do this activity at home. It's super easy. So here's what you're going to need. Okay, so the first thing you're going to need is a 2-liter bottle. Doesn't matter what brand, as long as it can fit about 2 liters worth of water inside of it. You're going to take the label off so you can actually see what's going on. You're going to need something that can hold air and trap air inside of it, sort of like straws when you fold them in half. I found these in the car. Yeah, you're going to do something just like this. You can also use just like little tiny baggies that you can like pierce down near the bottom with like a, what are they called? These little things, can't remember what they're called, but you can use these to just pierce a little hole through them, and then you're going to use these to create weight to drag this down. You can also use hot sauce packets or soy sauce packets. We can use pen or marker caps that don't have a hole in the top, just so that they can trap air inside when you seal at the bottom. Any of these will work. You might need some tape depending on what you use. If you find old strands of metal bracelets and necklaces, you can use these to hold the weight and carry stuff down. Little zip ties like this you can use to just try and wrap around like little screws and bolts to generate the weight. You just need something that can hold air inside and a way to weigh it down. That's the only thing you need, and everything you do has to be able to fit inside of a bottle like this. All right, so let's move on. So here are some examples of what you can do to make your little divers. See, in here I've got a straw that I folded and then I attached a part of a necklace to it. It's not that heavy, so it actually still floats, right? And then what I did here, I took a little sauce packet, a mild sauce packet because that's all they're good for, attached a little clothespin with a little bobby pin at the end for extra weight. As you can see in here, I already tried that, and I added 3 bobby pins, and that was too much weight. Now it's not rising up to the top. Another option, and I took a little permanent marker, and I drew a little diver on here, which is super fun. You can draw a diver, a submarine, a fish, jellyfish, whatever you want. I also took a straw. What you can do is just fold them over, bend them, pinch the edges to squeeze them into each other. I used little Ziploc ties and attach little screws and bolts at the end, and that just adds enough weight so that it'll just barely float when I put it in, right? But they'll still sink. So let's see how this works. So I've got 3 new models that we're going to test out. One here, obviously, I took off a couple of the little weights on the bottom here for the diver. I made a little submarine here on the back of this packet with a couple extra weights. We're going to test it out, see how that does. I took off a weight here and added a little bobby pin, just try and balance it out. It's all about balancing the weight so that you can eventually get it to go down while squeezing, but will stay up when you release all the pressure. So let's test this out first. We'll put this in. The water's gonna come out, that's fine. And then add a little bit of water, just make sure that it goes all the way to the top. Put on the cap, and let's squeeze, see how we do. There we go. That one works. Let's add in the scuba diver. All right. Add a little bit of water. Will the scuba diver go? And he does. Very cool. All right, next, let's try the little submarine. See a little submarine? Pretty cool, I think. I'm a professional artist. Yes, I am. No, I'm not. And let's put this in. Test it out. It doesn't sink right away. Add a little bit of water, fill it up to the top. And then add pressure. Will all three go down? Yes, they do. All right, cool. So what's going on in here? Well, I'll explain right now. Here is our bottle with our diver inside. Your diver can be made with just about any small container you have, as long as there is enough air trapped inside that it just barely floats to the top. This air bubble is important because it generates the buoyant force that lifts the diver up. Meanwhile, any weight that you add is going to fight the air force and pull it down, thanks to gravity. Normally, the density of water is 1 gram per cubic centimeter at room temperature, which is around 70 degrees Fahrenheit or 21 degrees Celsius. In order for the air bubble to float, it has to be less dense than the water, maybe like 0.9 grams per cubic centimeter or so. Now, as you squeeze the sides of the bottle, you're increasing pressure inside of the bottle. This compresses the water inside, which means that the amount of water stays the same, but it is forced to fit into a smaller volume. See? However, it's not the water itself that gets smaller, but the air bubble inside as the water squeezes around it, since gases compress before liquids do. As the air bubble shrinks, there's more air in a smaller space, so it becomes denser. Since the air bubble and diver together are now denser than the water, the buoyant force shrinks down and bloop, 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 bloop. It sinks all the way down. Then when you release the pressure, the air bubble grows, increasing the buoyant force, and whoop, 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 back to the top it goes. All right, everyone. We hope you enjoyed this video. Please like and subscribe for more of these from Liza, Amelia, and I. See you next week. Bye.